So this is the topic of wave speeds in GCSE physics, both for combined science and for physics as a individual science. Again, I will focus on Edexcel because it is mainly for students in my school, and we will look at one main learning objective, and that is recalling and using the wave speed equations. And there are two of these, and I will quickly go through the two equations and one example, and then I will set some examples, some questions for you to complete in your own time. There are two main equations. One is wave speed is frequency times wavelength, and let me just highlight it for you. So wave speed is frequency times wavelength. And then the second formula you should have come across before, that is speed equals distance divided by time. So the key learning questions you need to be able to answer: how can we calculate wave of a speed? How can you measure the velocity of sound in air or in water? And the wave equation, let's start with it. So as you can see, and I want to highlight key things here. Units are extremely important. So the first formula we're looking at, we're saying wave speed is frequency times wavelength. F for frequency, V for wave speed, and this lambda, this like upside down Y, is wavelength. Please note units. Wave speed is in meters per second Frequency is in hertz, capital H, little z, and the unit for wavelength is meters. The units are extremely important in this topic. Few figures to learn. Speed of sound in air is 330 meters per second, and speed of light in vacuum is 300 million meters per second. So you can see as light travels 1,000,000 times faster than sound. Okay, the second equation is wave speed is distance divided by time. Speed again meters per second, distance is in meters, time is in seconds. If you have questions where they give you distance in kilometers, you need to convert that into meters. And if time is given in minutes or hours, you need to convert that into seconds. Okay, let's look at an example. A surfer travels 52 meters on the front of a wave in 8 seconds. How do we calculate wave speed? Identify what you know. We know distance and we know time. So recall the formula. Because we know distance and time, so we need to identify the correct formula. The formula that links distance and time is wave speed is distance divided by time. Insert into the formula, and there is your answer. And don't forget the units. So 52 divided by 8, 6.5 meters per second. Again, a couple of questions which you can do in your own time. Calculate the speed of light which travels. You know your distance, you know your time. And you can also have a go at question 2. You hear thunder 5 seconds after you see lightning. Sound travels at 350 meters per second. How far away is the lightning strike? This time you need to work out distance. Please note you do need to rearrange formulas. If you don't know how to rearrange formulas, then my advice would be just learn the formula triangle. However, I advise you to learn the rearrangement of formulas. Second question or second example, we know wavelength. So some waves have wavelength of 13 meters. Frequency is 0.5 Hertz. This time we know wavelength, we know frequency. So the equation to recall this time is speed equals frequency times lambda, wavelength. Insert or substitute the figures 13 meters times 0.5, 6.5 meters per second. And there are a couple of questions which you can do in your own time, and you can pause the video here. And there is an exam style question. Humans can hear sounds at wavelength of 16. Look, you know the wavelength, you know the speed, you need to calculate frequency. So because this question involves frequency, so you have to recall this equation where speed is frequency times lambda. So in summary, this topic is about recalling two formulas. Wave speed is distance divided by time, or frequency times lambda or wavelength. Now, what is sonar? Sonar is a signal which ships and submarines send to the ground, to the bottom of the seabed, in order to find the depth of the sea. And what happens is that a sound signal is sent through the water. It hits the bottom of the sea depth or seabed, sorry, and then the signal comes back. Now we know the speed of sound in water, so we will say the speed is distance divided by time. So distance equals speed times time. So you know the speed of sound in water, you multiply by the time it takes for the signal to come back. That will give you the total distance traveled by the sound wave. Please remember it's there and back. So the actual depth of water, you have to divide the answer by 2. A few more questions which you can practice in your own time using the formula speed is frequency times wavelength. Lastly, just to finish, how do you measure the speed of waves? You can find the speed of sound by measuring the time it takes for sound to travel a specific distance. So if you stand in front of a large wall, you can measure the time it takes for an echo of a loud sound to reach you. So you measure the distance between you and the wall, and then you measure the time it takes for the echo to come back, and then speed is distance divided by time. One way of measuring speed of waves on water is to measure the time it takes for wave to travel between two fixed points such as buoys. The speed can be calculated from the time and distance between the points. You just need to know this slide, and for a few marks, 2 or 3 marks, you need to be able to describe how you can measure the speed of sound in air and how you can measure the speed of sound in water. Look at the diagram. It takes 7 seconds for a wave to move from one ladder to another. Calculate the speed. So speed is distance over time. The distance is 10 meters. Time is 7 seconds. So the distance is 10 meters. Time is 7 seconds. So speed is distance 10 divided by time 7 to give you your answer. And that's it for the video on wave equations.